Hey guys, it is Mrs. Lozano. Today we are doing lesson 58 in advanced math. Here we go. The first part of this lesson is about the distance from a point to a line. I am going to draw the first one so that you can kind of understand what they're asking. It says find the distance from point negative 3, 5. So here's point negative 3, 5. To the line, and the line 1/2 x plus 1. Now, I did the math quickly so that I could graph this. If I plug points into the 1/2 x plus 1, when 2 goes in, I get 2 out. When 0 goes in, I get a 1. And when negative 2 is in for x, I get 0. So if I were to draw this line, it's going to look something like this. Now, what the question is asking is what is the distance between the green point to the blue line? So if I were to draw it, it's going to look something like this. Now, remember lines go on indefinitely. So the way we are going to solve this is we are first it's 3 steps. First thing we're going to do is find the equation of the perpendicular bisecting line, okay? That's the orange line. We know how to do that. We look at our original line. We know that if something bisects it perpendicularly, we need to take the negative reciprocal for the slope. So I end up with y equals negative 2x plus b. I don't know my b point. The only way to do that is to plug in the point that I do know. I probably should have written that on here. I know this is negative 3, 5. So I'm going to plug that in here. My y is 5, negative 2 times negative 3 plus b. This means I have 5 equals positive 6 plus b. Subtract 6, that means negative 1 is my b. So the equation for this orange line is going to be y equals negative 2x minus 1. Okay? All right, that's step 1. Step 2 is find the intersection point. Write that down. Okay, so what does that mean? I'm looking for where these two lines, the orange one and the blue one, intersect. I'm drawing a big giant red spot on it there. That's where the two intersect. In order to find what that actual point is, I have two options, or the way I do it is I set one line. I set my original line up here equal to the perpendicular bisector line. When I set them equal to, I'm saying where do those two lines have the same point? Where do they meet? So I'm going to drop my y's and I'm going to say 1/2 x plus 1. That's my original problem equation, has to be equal to my perpendicular bisector equation, negative 2x minus 1. When I set those equal to each other, I'm going to solve for the x. I'm going to move my x's to the left and my numbers to the right. I know it's tempting to move it the other way so that you get a 0 over there. Go with the way I'm doing it. It'll make your life a little bit easier. All right, 1/2 x plus 2x. I know is 2.5 x's. I'm going to just do that math like that in my head. Hopefully that makes sense. If not, find your common denominator. 4 over 2 plus 1/2, 5 over 2. All right, to get x by itself, I need to do the reciprocal. Multiply both sides by the reciprocal. When I do that, these cancel, and x is going to equal negative 4/5. In order to work with this problem, it would be much easier if I had them in decimals. You can pop it in your calculator if you need to, but that is the same as negative 0.8. Now, I have part of my coordinate. I need to find the y. In order to do that, I'm going to plug in the answer that I got back into either of the equations. I'm going to take that 0.8 and plug it into the perpendicular bisector, the orange equation, and I will end up with y equals negative 2 times negative 0.8 is my x minus 1. That means I end up with 1.6 minus 1, which means I end up with 0.6 for my y. Okay, so altogether, the point is, they intersect at negative 0.8, 0.6, okay? If you had the fractions, that's fine. I suggest turning them into decimals by the end of this step because it will make the next step easier. All right, the last step we do to solve this equation is we're going to use our distance formula, and I'm running out of room, so I'm going to do it over here in the corner. We're going to use the distance formula to find the distance between the red dot and the green dot because it asks us to find the distance between that point and the line. And so obviously the red dot is a point on that line. All right, to do that, it's distance equals x1 minus x2, square all of that, plus y1 minus y2, square that. All right, either one can be your x, either one can be your y. So I end up with, let me go ahead and label this point. This is negative 0.8, 0.6. So if we do our x's, I have negative 3 minus 0.8 squared, plus my y is 5 minus 0.6 squared. These become positive. I end up with negative 3 and 0.8. If I were you, I'd just put them in your calculator at this point. I will do a little bit more by hand for you guys. 5 minus 0.6 is 0.4 squared. Stick that in your calculator and you should get the distance is equal to 4.92. And that is the answer to the problem. Not too bad. All right, let's do one more example. When I do this one, if it helps for you to draw it, go for it. I'm going to do it without drawing it to show you that you can do it. So step 1 is the perpendicular line equation. Okay, we're finding the distance from negative 1,5 to the line y equals negative 1/3 x plus 4. I know that my slope is going to be the negative reciprocal of the line that I have, the slope that is. So I know it's going to be 3x is going to be, I should say the m is 3. There you go, not the x. All right, so if I build my equation, I'm going to have y equals 3x plus b. I need to plug in my point up here to solve for my b. So I'm going to have 5 equals 3x. Oops, not x. I need to put the negative 1 in there. 3 times negative 1 plus b. That's going to end up with 5 equals negative 3 plus b. I'm going to add 3 to both sides. That means my b equals 8. So I end up with y equals 3x plus 8. All right, step 2. I need to figure out where those two lines intersect. Okay, to do that, so I'm looking for intersection point. All right, to do that, I'm going to set both of my equations equal to each other. Okay, I'm going to do negative 1/3 x plus 4 equals 3x plus 8. Sorry, that didn't write very well. All right, I'm moving my 4 over to the right. I'm moving my 3x to the left. No, those don't cancel. All right, this becomes a 4. This cancels. This cancels. I have this 3x can become a negative 9 over 3. So I have common denominator, which gives me negative 10 over 3x. That's supposed to be an equal sign right there. Multiply by the reciprocal. Negative 3 over 10. These cancel, and I'm left with x equals, let's reduce these first, negative 6 over 5. Again, this is a good opportunity to go ahead and change it to a decimal, which should be negative 1.2. Now we need to find the y point. To do that, I'm going to plug it back into one of these equations. I like to do the one without the fraction. So I'm going to go with y equals 3 times my x, negative 1.2, plus 8. This is going to be negative 3.6, I believe. Did I do that right? I think so. So y is going to equal 4.4. Let me double check that. Yep. So y equals 4.4. So my total point is negative 1.2 and 4.4. All right. Last step. We need to now find the distance between the 2 points I have. So here's 1 point. back up to my original problem, and I have my second point. So over here, distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. All right, let's plug in what we know. x1, I just use the top point, minus the bottom point, negative 1.2 squared, plus y1 is 5 minus 4.4 squared. We can actually do a lot of this one by hand, or you can use your calculator. Make it look a little cleaner. Okay, negative 1 plus 1.2 gives me 0.2 squared. Plus 5 minus 4.4 gives me 0.6 squared. 0.2 squared is 0.04. 0.6 squared is 0.36. So we're going to have the square root of 40. Put that in your calculator, and you should get the distance equals 0.63. There you go. All right, hopefully that's not too bad. I feel like it's all math we've done before, so hopefully that is not too hard and you can do it. Let's shift now to the second half of the lesson. Second half of the lesson is about parabolas. What we've learned, all the parabolas we've done so far have been kind of standard parabolas. We're learning today about wider parabolas and narrower parabolas. So first look at this parabola I have in the center. Here's the equation of it. Y equals negative x minus 1 squared plus 2. That's the format we're used to. As a reminder, the negative 1 right here tells me our x-axis of symmetry. Remember, it's always the opposite sign. So right here is where my parabola is going to be symmetrical or bend around it. The plus 2 right here tells me that that's the y point for the vertex, and the vertex is always on the x-axis of symmetry, so my vertex has to be here. And then remember, this negative tells me that it's going to open down. You would need to plug in 2 points to solve for a point on either side of the x-axis of symmetry so that you have an idea what the shape is. All of the parabolas that we've done so far have this basic shape, okay? It's just moved up higher or shifted to the left or right, but they have the same shape. Today we're learning what happens when you have a narrower one or a wider one. If you look at the graph on the left, you will see it is much narrower. The reason it is narrow is because of this 3 at the front of the parentheses. That 3 causes it to become narrow, and I'll show you why in just a second. Note that it's the same vertex. It's still negative and opens down. It's the same x-axis of symmetry. The only thing that's changed is that number that it feels like a coefficient in front of the parentheses is what changes the shape of it. Slide over to the graph on the right, and you see a much wider parabola. When we have a fraction in front of the parentheses, it feels like a coefficient of that completed square. That will make the parabola much wider. Again, same vertex, same x-axis of symmetry, same shape opening downward, just much wider because of that 1/3. All right, let's go through some examples. I'm showing you what they could look like. What the purpose of this lesson is to learn how to complete the square for a narrow or wider parabola, and then also to graph it. Remember, this problem, the example is complete the square to graph the parabola, and there's the equation for it. There are 2 steps to this problem. You must complete the square, so I need to see you finding the correct equation for it, and then you must graph it. Some of you are like, I'll just stick it in my calculator, it'll be great. I don't recommend that, because when it gets to a quiz or a test, I will be looking for that equation, and if you can't find it, it will be wrong. Okay, so on that happy note, here's how we do this. First, we are going to work on our equation to get it in the right format so that we can graph it. Notice I moved the 3y, I kept it on the left, I moved everything else over to the right side, which changed the signs for all of those. You cannot graph a parabola with a coefficient on the y, so I'm going to have to divide everything by 3 to eliminate that. I will end up with y equals 1/3 x squared minus 2/3 x minus 5/3. Now, I don't know how to do, I'm actually going to do one thing first. First, when we would complete the square, we would create parentheses like this. And then we put that negative 5/3 over here. Everybody okay with what I did there? I just moved it into the format we're used to working with it. Now, if I'm just focused on what's inside the parentheses, I need to complete the square there. I need to figure out how to make a perfect square so I can factor it. The problem is we don't know how to do that when we have a coefficient on the x squared. So before I can complete the square, I actually have to factor out that 1/3. That's going to create the narrowing or the widening of the parabola. So if I rewrite this, I now have 1/3 is going to come out of the parentheses. Not sure why there was a little negative there. All right, and it's going to be x squared minus 2x. I'm leaving my gap, minus 5/3. Notice I didn't take the 1/3 out of the 5/3 because I'm only factoring what's in parentheses. And also notice that when I took the 1/3 out of the 2/3 x, I know why the 1/3 looked funny. If you're not sure, go back and re-multiply it out, distribute it. So if I did that, 1/3 times x squared would be 1/3 x squared, and 1/3 times 2x would be 2/3 x, which is what matches. Okay, make those go away. All right, now that we're here, I know it looks a little bit different, but now we're actually at the part where we're going to do kind of what we normally do. We're looking inside the parentheses. I'm going to look at my x term, and I'm going to say, okay, -2. I need to multiply by 1/2 or divide by 2, either one, and then I need to square it. When I do that, I'll end up with -1 on the inside squared, which gives me 1. Now, remember what we normally do is add 1 here, subtract 1 here. The only problem with that is because I factored that 1/3 out, when I subtract 1 here, I actually changed the value of my equation. I did not end up with a net value of 0 because 1 multiplied by the 1/3 is going to give me 1/3, and then I subtracted 1 over here. So what you're going to have to do is if you add a +1 here, you've either got to do the math and realize that 1 times 1/3 when it's distributed means this needs to be a -1/3. Your other option you can do is you can always say I'm going to do the opposite sign of what I put in. So I put a +1 in, I'm going to do a -1, and then I'm going to multiply it by whatever this coefficient is, 1/3. Either one will work. It's technically the same math. It's just a different way. If you like the multiplication, go ahead and leave it there like that, okay? If I start simplifying my equation, I now have y equals 1/3. When it gets to the factoring, that perfect square now becomes x minus 1 squared. Remember, this -1 is how I know how to put it in here. Hopefully you remember that. And then back here at the end of my equation, I'm going to simplify. I have -5/3 and -1/3. That's -6/3, which is actually the same as -2, or as 2, yeah. So if I simplify my equation, I end up with 1/3 x minus 1 squared minus 2. There's step 1 in our problem. Step 2 is go ahead and graph it. Now, looking at what we have here, we do want to remember some of those tricks that we know to help us set this up. The first one I'm going to do is to look and say, where's my x-axis of symmetry? It's right here. Same thing we've done in the past. You don't need to multiply by the 1/3. It's going to be x equals +1. Reverse your sign. So my x-axis of symmetry is going to be right here. I'm going to look back here and realize that this is my vertex, the y point. The y is going to equal -2. Keep the sign. Don't change it. Okay, it's always on the x-axis of symmetry. Now I need to find 2 points. I need to find 1 point to the right of the x-axis of symmetry and 1 to the left. This is not tricky, but maybe something you need to think of. I'm looking for a multiple of 3 to be inside my parentheses so that it will easily cancel out with that happy fraction I have. So I'm going to do x equals 4 is what I'm going to do to start with. So y equals 1/3. I'm going to do 4 minus 1. There we go. Minus 2. 4 minus 1 is going to be 3. 3 squared is 9. So I'm going to have 1/3 times 9 minus 2. These will cancel and become a 3. So 3 minus 2 is 1, so y equals 1. So my point is going to be 4, 1. When x is 4, y is 1. So I got 1, 2, 3, 4, and it's 1, 4, 1. Okay, there's that point. I need to do a point on the other side. You have two options. You can kind of do the math and figure out what would work on the inside. Again, I'm looking for a multiple of 3, like I want 3 on the inside if possible. To get 3 on the inside, I do x is negative 2. When I say inside, I should have said inside of the parentheses. So, okay, y equals 1/3 negative 2 minus 1 squared minus 2. If you're wondering why I said I wanted to equal 3 on the inside, it's because the denominator of the fraction is 3. So it's work with that. If you've got a fraction, try and get it to cancel. Once I do this, I have 1/3. I'm just going to work, there you go, times negative 3 squared minus 2. Negative 3 squared is 9. 1/3 times 9 is going to be 3, so I'm going to end up with 3 minus 2, which is 1. So negative 2 gives me 1, 2. So here's negative 2, here's 1, and here is your graph. I said there was two different ways to find the numbers. I want you to notice if my x-axis of symmetry is at 1 and I got 4, 1, I moved over 3 places and got 1. I should be able to move 3 places from the x-axis of symmetry line the opposite direction, 1, 2, 3, and that point should also give me the same output. If I moved 3 places to the left from my 1, I'd go 0, negative 1, negative 2, so I could plug negative 2 in and verify that I get the same 1 output, which I did. Hopefully that helps you kind of navigate figuring out the number when you've got a weird squared one. All right, that's your answer to this problem. We're going to try one more example, and then you guys are done. All right, example 58.4. Complete the square to graph the parabola. Y plus 2x squared plus 12x plus 17 equals 0. All right, same thing. I need to work on my equation and get that in the right format. So y is going to equal, I'm moving everything to the other side of the equation. Now, I'm going to right off the bat move that 17 and create these parentheses, leave the 17 hanging out by itself out there. I cannot work with the coefficient on the x squared, so I'm going to need to factor that out. So here we go. The negative 2 comes out. It leaves x squared inside and plus 6x on the inside, because negative 2 times 6x is negative 12x, which is what I have there. Leave my parentheses and my 17 there. All right, I will say at this point, pull that 17 out first. Don't try to factor the 2 out and then move it around. You're gonna make yourself crazy. Move the 17 outside of the equation, of the parentheses, and then just work on that, the problem pieces within the parentheses. Okay, I need to complete the square to figure out what to add inside my parentheses. Remember, I take that 6, divide it by 2, or multiply by 1/2, same thing. And I'm going to get 3 squared, which is going to equal 9. So I need to add 9 in here. Now, I need to subtract 9. When I subtract 9, though, remember, I either have to distribute beforehand and realize I actually have a negative 18, or I can leave my negative 9 there and I multiply by whatever I have up here at the front, what I factored out. You do need to take the sign. It's not just a 2. You have a negative 2 at the front, and then the math will work correctly. Okay, when I do that, I end up with plus 17 plus 18. Did I do that right? Yes, I did, but I messed up my sign up here. So math teachers make mistakes. Look up here at the top. I had a plus 17. I needed to move it over here. I did that right here, but I forgot to change my sign. Here and here it should have changed too. Some of you guys have been waiting for me to catch that for like 3 minutes. I'm sorry about that. Hopefully that makes sense and you see the error. I apologize for that. Welcome to hard math. Teachers make mistakes. All right, I'm going to bring the rest of this down, negative 2. I'm going to factor my x squared plus 6x plus 9. It's going to be plus 3. Remember, that's whatever's inside over here when you found your complete the square. That's what goes there. And this is squared. All right, when I simplify the back end of this, it ends up just being +1. Thank you, Jesus, because that would have been a pain to graph if it was a really giant number. All right, there's my equation simplified. And now I can start graphing. Okay, a couple things that we know. It's got a negative at the front of it, so it is going to open down. So be prepared for that. Let's go over what is our x-axis of symmetry. Our x-axis is going to be -3. It's right here. Opposite sign. So 1, 2, 3. There you go. There's our x-axis. All right, our vertex is going to be at 1. I'm sorry, the y is 1. There we go. All right, so y right here. So there's my vertex right there. Okay, I need 2 points. I don't have a fraction, so I don't have to use big or small numbers or some specific number. Know that it's going to get squared, so don't use 5, because 5 plus 3 is 8, and 8 squared is 64 times 2. It's not going to be anywhere close to my graph. So we're going for smaller numbers. I'm actually going to choose to use -2 to start with. So I'm going to have -2, -2 plus 3 squared plus 1. I'm going to end up with -2. Inside, I'm going to have 1 squared plus 1. And that's going to give me -2 times 1 plus 1. -2 plus 1 equals -1. So this point is going to be -2 minus 1. So when I graph that -2 minus 1, here we go. And then I'm actually going to go ahead and just use -4 for my next one. So when I do that, I'm going to have -2, -4 plus 3 squared plus 1. That'll end up with -2, -1 squared plus 1. That gives me -2 times 1 plus 1, which gives me a -1 again. So my point is going to be -4, -1, -4, -1. Oh, there we go. All right, and here we go. Because I had that whole number, it gets to be a very narrow graph. I didn't graph that very pretty, but you got the idea behind it. All right, guys, that's it. I hope it made sense. If you have questions, always reach out. Have a great day. See you in class soon.